Hey guys, we're looking at Meyer line. This is question number 3, and we've got a problem based on a school track and field competition. The table below lists the height jump by 14 competitors in the high jump according to their age. And so the first thing I want you to notice about this problem is typically you would see, two columns side by side of age and height. In this case, it's been broken into two, and that's just because the columns are too long to fit the paper. And so don't get fooled. It's really just the same set of information just cut in half for you, which is kind of good for the Meyer line because we have to do that anyways. And so this side here on the left is what we're going to use to calculate our x1 and our y1 right in there. And over here we'll have our x2, and over here our y2. And so it's the first xy that we'll get the average of, and the second xy over here that we'll get the average of. And so I cheated a little bit and did a couple of those calculations for you in advance. We're going to get our x1 average right here. So when I add up 8 plus 8, 9, 9, 9, 10, and 10, I get 63, which then has to be divided by 7 because, of course, there are 7 x values there, which is going to give me an average of 9. And on the y1, 81, 85, 88, 100, 99, 95, and 110, that's going to give me 658 divided by 7, which is a 94. So x1 is equal to 9, and y1 is equal to 94. On the right-hand side, we do exactly the same thing. I'm going to get the average of the ages here on the second set of the data, and then the average heights. We'll call those x2 and y2. And when I get the average of the x's, it's going to be x2 will be equal to 119 divided by 7, which comes to 17. And the y2, when I add up 150, 160, 168, 165, 170, 177, and 172, it's going to give me 1,162, which I'll also divide by 7, which gives me an average of 166. So the averages for both sides have been done. Now, I have to go ahead and get the equation of the line that we're going to use to predict the answer to the question that's being asked, which is about the age. So we need to find the equation of that line, and y is equal to ax plus b, which means I need the a. And to get the a, we're going to do the slope formula, y2, 166, minus y1, so it's minus the 94, over x2, 17, minus 9. And when we simplify all of that, we get 9 for the a. 72 over 8, which gives us the 9. After that, we get our b. And the only tricky thing to remember when you're going to get the b is the x and the y can't be any random point from the table. The x and the y must be one of those two sets of points that we calculated. So either it's going to be this xy right here, or it's going to be this xy right there for the substitution. And so we're going to get y is equal to 9x plus b. So there's the slope been put in. Now I'm going to go ahead and get an x and a y, which I'll use x1 and y1 right over here. So 94 is equal to 9 times 9 plus b. 94 is equal to 81 plus b, and when we subtract the 81 from both sides down here, 13 for the b. So because of that, we have our rule, y is equal to 9x plus 13. So now we just have to stop and take a look at the question and to determine which substitution we're going to have to do. So given the above results, how high could a 13-year-old child be expected to jump? So the age that we're being given is 13. That's an x. So that means we're going to put a 13 right in there for the x, And we're going to solve the y, which would be the height that that kid could jump. So 9 times 13 plus 13. That's going to be 117 plus 13, which is 130. So we could predict, based on the equation of the line that comes from the averages of the two sets of x's and y's, that the y, or the height, would be equal to 130 centimeters. And that is the last of the Meyer line.